Hello everybody, my name is Zohir Chaudhary and today's topic is about criteria air pollutants, and we'll be focusing on three criteria air pollutants: nitrogen oxides or NOx, sulfur oxides or SOx, and ozone O3. So there are six criteria air pollutants: lead, carbon monoxide, nitrogen oxides, sulfur oxides, ozone, and particulate matter PM10 and 2.5. And as I mentioned in the introductory slide, our focus will be on nitrogen oxides, sulfur oxides, and ozone. Nitrogen oxides is expressed as NOx to designate the various oxides form of a nitrogen, and the sulfur oxides is expressed as SOx to designate the various oxide forms of the sulfur. In general, SO2 or sulfur dioxide, because it's dominant, that's instead of SOx. Sometimes we also say sulfur dioxide. So NOx and SOx. NOx or nitrogen oxides, the major sources are from vehicles and industry, and it is an ozone precursor, which we'll discuss about ozone in a few minutes. What precursor mean? That it is used in the formation of ozone. And in terms of health outcomes, it is a mild respiratory irritant. And the major oxide forms are N2O, nitrous oxide, NO, nitric oxide, NO2, nitrogen dioxide, then N2O5, nitrogen pentaoxide, and as well as ammonia. But the dominant form that is known as NOx, it's a combination of NO and NO2. So these two together is known as NOx, NO and NO2, not the other ones. Sulfur oxides or SOx, the major source of SOx is power plants that uses high sulfur coal, as well as diesel also, because diesel also has sulfur in it as a contaminant. Once diesel or coal is burned, it produces SO, sulfur oxide, as well as sulfur dioxide, which eventually, with more oxygen, it becomes sulfur trioxide. However, in the air, sulfur dioxide is more dominant than the other ones, and so sulfur oxides is mostly expressed in terms of sulfur dioxide. With respect to health outcomes, sulfur dioxide or sulfur oxides combined, they are a respiratory irritant. Both NOx and SOx, they lead to acid deposition. They can be dry deposited in the soil from the air, or they can be wet deposited. Wet deposition means the rain combines with the NOx and SOx that is floating in the air, and eventually NOx and SOx, they become nitrogen dioxide, nitric acid, and sulfuric acid. So NOx become nitric acid and SOx become sulfuric acid, and it leads to significant acidity in the rain. In fact, you can see that in the West Coast, the pH of rain is relatively not very acidic. It is mildly acidic. Typically rain is mildly acidic, but as you go to the East Coast, mostly in the Northeast and Southeast, you can see that the pH in the rain it's much lower, and the reason is that there's a lot of coal burning power plants all over here, which leads to a significant amount of SOx in the air, which in turn leads to sulfuric acid and increases the acidity in the rain. The last criteria pollutant that we'll discuss is ground level ozone. It is also known as smog. So let's not confuse ground level ozone with stratospheric ozone. Both stratospheric ozone and ground level ozone, they are the same chemical, ozone. However, the ground level ozone is the one that causes major problem to health, because it leads to organisms not being able to tolerate the higher level of ozone at the ground level, whereas if ozone is in the stratosphere, is extremely protective because it absorbs ultraviolet radiation and leads to protection of skin and many other issues that can arise from high ultraviolet exposure. So the chemical reaction between NOx, which we introduced earlier, and VOCs, also which stands for volatile organic compounds, together in the presence of sunlight leads to ozone formation. So ground level ozone is formed when you have NOx, nitrogen oxides, VOC, volatile organic compounds, and you have sunlight as well as heat. Together, this leads to the reaction moving forward and producing ozone at the ground level, or at the level where we all live. So when does high ozone rise and where? Because of the sunlight and heat, we'd expect high ozone in the summertime. And where? You can pretty much imagine anywhere where you have all of these ingredients, NOx and VOCs, and you can see that NOx and VOCs, they arise from industrial stationary sources as well as mobile sources such as trucks and vehicles. So typically cities and nearby cities, areas where there's a lot of industry and vehicles, and you have a lot of sunlight, so next to the tropics or higher latitude where there's enough sunlight and heat, especially in the summertime. Ozone, there's no threshold. What no threshold means is that any concentration, even small, can lead to adverse health effects of ozone. Acute exposure to ozone leads to coughing, chest pain, headaches, eye and throat irritation, nausea, asthma attacks, as well as loss of lung capacity and respiratory damage. But ozone also has chronic exposure. So with repeated chronic exposure, it leads to changes to immune system, aging of lung tissue, loss of lung tissue, susceptibility to respiratory infection, and so a lot of problems from ozone exposure. And ozone, unfortunately, in the US, it's a main cause of concern. Over 50% of the US population resides in areas that are not in attainment, which means that it does not meet US EPA national ambient air quality standards. As a result, a lot of the people in the US, they are at potential risk of high level of ozone related health effects. Houston is one example, as well as Los Angeles, that is always in the news among the worst cities in the US, as well as Atlanta, Georgia, Denver, Phoenix. I think these are also up and coming over the last few years. And in North America, Mexico City has the highest ozone levels. Okay, so that's a quick introduction of criteria, air pollutants, NOx, SOx, and ozone. Thank you for listening.